Hi everyone, welcome back. In this section, we'll have a look at how a drone works at the most basic level, followed by an overview of some of the design variations out there. If you want to jump straight into the juicy bits, you can skip ahead to the next section where we dive right into the understanding all the components and building the drone. Okay, so the term drone is not really all that descriptive. Technically, anything remotely controlled or pilotless can be called a drone. Even male bees are classified as drones. When we talk about drones in this course, we are talking about multirotors or multicopters. And to qualify as a multirotor, it has to have two or more main rotors that provide lift, as opposed to say a fixed-winged aircraft such as an airplane. And to distinguish between the various types of multirotors design, we use the number of rotors they have as a guide. Moving forward, for the sake of keeping things simple, I will refer to multirotors as drones, and we'll use the term motors instead of rotors. So, let's have a look at how a drone works at the most basic level, and we'll use a quadcopter as an example. A quadcopter design has 4 motors. It is one of the many drone configurations out there, and it has a lot in common with one of the most iconic flying machines, the helicopter. However, unlike the helicopter, the quadcopter uses 4 motors, 2 are spinning clockwise, and the other 2 are spinning counterclockwise to provide balance. Motion is achieved by changing the speed of the motors, and everything is controlled by a tiny onboard computer called a flight controller. It tells the motors how fast to spin depending on the input from the onboard sensors and the pilot. So let's have a quick overview at a few drone configurations, starting with the quadcopter as just discussed. The quadcopter has 4 motors mounted on a symmetrical frame with 4 arms. The arrow indicates which direction the aircraft flies when going forward. You can build quadcopters in different designs as well, but the most common one is the X-shaped design. This is because the X style provides the best flight characteristics. You have access to a more stable thrust and maneuverability since you have 2 motors at the back, and in case you want to mount a camera on board, an unobstructed view. Next up, if we take away one motor, we have the Tricopter. It works by using 3 main motors set up in a cool Y-shaped design. All the motors usually spin the same direction. The arrow indicates which direction the aircraft flies when moving forward. The tail also uses an additional servo motor in order to manipulate the direction the aircraft flies. This configuration is slightly cheaper to build since you are only using 3 main motors and all the propellers are the same shape. Another advantage of this design is that it produces an aircraft with incredible agility and very fun flight characteristics. On the flip side, however, this design offers less stability than other configurations, and the mechanism required for the tail is not as robust during crashes. Additionally, as you can imagine, this design would come with less lifting power as well. Next, we have the Hexacopter. It flies with the help of 6 motors on a symmetrical frame. It's very similar to quadcopters in terms of flight mechanics. In this instance, there are 3 motors that spin clockwise, while the other 3 spin counterclockwise. The arrow indicates which direction the aircraft flies when moving forward. Having more motors means the aircraft can carry heavier things, and if during flight one of the motors fails, it can still land safely. The downside to this design, however, is that it uses more motors and needs more battery power, so it's slightly more expensive to build. Finally, let's have a look at the Octocopter. It flies with the help of 8 motors on a symmetrical frame. The flight mechanics are still pretty much the same as the quadcopter. In this instance, 4 motors are spinning clockwise, while 4 are spinning counterclockwise to provide balance. The arrow indicates which direction the aircraft flies when moving forward. You can almost see this as an upgrade to the Hexacopter in terms of lift capacity, and it can land safely even if 2 motors fail during flight. The downside of this configuration, of course, is that 8 motors will need a lot of power, so you will need to have multiple high-powered battery packs, which can get a bit expensive. One of the main uses for this type of drone is to pair it up with professional video equipment that would otherwise be too heavy to carry for other type of drones. Amazing! This concludes our quick intro into how a drone works and some of the popular designs out there. Next, you can check out the jargon buster and the tools requirements before heading over to section 3, where we will finally start putting together the drone.